Let's start from blank slate all over again. And this is the file. The name of the file is finance customer data 5 million, which contains 5 million rows, and the size is pretty big. We have already used this file to load the customer table in Aurora. Now let us write the code. First of all, we'll have to install Flask caching. And to do that, we'll have to run pip3 or pip install flask-caching. Note the capitalization. I have already installed it. So once the installation is done, let us import all the libraries that are needed. The first one is Flask. I'll need PyMySQL also because I'll be connecting to Aurora MySQL database. And now a new import, which is Flask caching. So from Flask_caching, from this particular module, I want to import the cache class, which is the second step, wherein we'll be importing the cache class from Flask_caching. Then as usual, we'll create app. Now after creating app, we'll have to initialize Flask caching also. So for that, we'll have to create a cache object, which will use the cache class, and we'll have to pass certain configuration. And I'll pass this configuration cache_type equal to simple cache. So what it will do, it would use the memory that is available in my machine to implement a simple caching layer. I can use memcached and Redis also. So I'll talk about the configuration after the hands-on, but right now I'll be using simple cache. I do not want to use Redis for application cache. Now here, remember, we are doing application caching, and instead of using simple cache, you can use Redis or memcached also, which would be centralized distributed caching. I don't want to make this complicated, so that's why I'm using simple cache, which will use my machine's memory to implement the caching layer or application caching layer. Then I'll have to initialize using cache.init_app. This is the method, and I'll have to pass the Flask application, which is app. So the object that I have created using the cache method, I have instantiated the object using the cache class, by passing some configuration. So this is a cache object which has been created from cache class that I imported from Flask_caching module or library. Now after this, I use the init_app method, which is available in the cache object, and I pass the argument, and the argument is the name of the application, name of the Flask application, which is app that you have created. So this is done, and this is how we initialize the caching layer. And now I'll define a generic function which will connect to the database and return a connection object, which we have done earlier also. And this is what it is. I'll put the password later on. And this is the Aurora endpoint that I have created. The user is admin. The database is FinanceDB. Now let us go ahead and implement the APIs. First, we'll implement the get customer details. Now this one would be without caching. So I'll just write the code block for this entire function. Nothing special would be done here. So let me just write the code and then start the video again. Okay, so this is the code connection. I'm getting the connection object, opening a cursor. I'll be passing customer ID. Request has not been imported. So let me import request also. And this is the SQL statement wherein I'll get all the columns from the customer table where customer ID equal to certain value, and we'll be passing the value using query string. I'm initializing data as an empty dictionary, item list is an empty list, and then fetching all the records after the cursor execution is done, and then I'm putting it in the data dictionary and appending it with the item list and returning the item list. As simple as that. Again, nothing special. I'll be creating one more function with the exact same logic, but the name of the function would be different. And I'm naming the function to be get cust details cached. So here I'll implement caching. All right, so let me write the code all over again. So same thing, nothing changes. It's the exact same code that I have written here. I have just copied and pasted. And obviously, finally, if name equal to main, then run the Flask application. All right. So first, let us implement the API, and the API for this one would be, or the URL endpoint for this one would be app.route, and I'll use get customer details but without the underscore. This is done. The same thing would be done for this one also, but I'll have cast at the end. So again, nothing special. Everything is same as usual as earlier, but we'll change or we'll add a few things now. For this particular URL endpoint, I do not want to use caching. I want to use the plain simple Python application which will read from the database and then return it. But for this one, I will use caching. And how do I do that? Again, we'll use a decorator, cache.cast. That's it. You can mention the timeout, but we'll not mention timeout right now. I'll show you how timeout can actually impact. All right. Anyway, this is how we implement caching. The very first time, the value would be retrieved from database, and next time onwards, it would be retrieved from cache. So let us run this application and go to Postman and send the API request. And what will I do is that I'll use a customer ID 106, and the name of the customer is Fidela Scholz. The application has started. This is my Postman, and the endpoint is get customer details, and I'll send cust_id equal to 106. So it will show us the execution time also. So let's send this request. Okay, there's some error password. Okay, I did not provide the password. Let me provide the password and come back. Let's try it again. And it is executing. So it is taking quite some time because as you know that the table has 5 million rows. And see the execution time, it took 7.04 seconds. And if you hover over 7.07 seconds, it will tell you where all time went. So the prepare is only 2.71 seconds. Socket initialization, which is used for sending the request, there's no DNS lookup needed. TCP handshake also take very less time, but waiting took the most time. It is waiting on the server side or on the database side. This waiting TTFB is actually waiting at the server side. Now, why it was waiting at the server side? Because the server was trying to fetch the information from database, which was taking fair amount of time. Okay, it was 7.04 seconds. Let's send this again. This is the second time. Let's see what the execution time is now. It is 7.12 seconds. I'll execute it 2 more times. This is the third time, which would also take somewhere around 6 to 7 seconds. So 7.06, and there's the last time. On an average, you are seeing that this particular API is taking 7 seconds to fetch the result, and the last time it was 7.16 seconds. Now obviously this is not acceptable for any application. To get a single customer, if you need 7.16 seconds or 7 seconds for that matter, that would not be acceptable for most of the organizations. And I have not done any database optimization here. I have kept the database suboptimal just to show you how caching helps. So let's say the database is as such that it has billions of records, and it actually takes 7.16 seconds, and it is not acceptable by the customer or by the business. So now what will I do is I'll use the other API, which get cust details cast, and send the request the first time. So it is also taking some time, which is fine. It took 7.24 seconds. So this is the first time. Let's send it again. And now you see it is taking only 4 milliseconds, again 4 milliseconds, 3 milliseconds, 4 milliseconds. So it is within 3 to 4 milliseconds. So the execution time has reduced drastically. Imagine from 7 seconds to 4 milliseconds, or from 7,000 milliseconds to 4 milliseconds. More than 1,500 times less. So if I use the same customer ID, it will get the record from caching, application caching, and send it to us. Because we have not mentioned any timeout, the data would be there in memory till the time the application program is restarted or there's no space in memory. But before that, let us try one more customer ID, and it would be 436 this time. Now you see, even with 436, we are getting the same customer ID, which is 106. Why that is the case? Because it is using this API endpoint to get the customer information. And if I use get customer details, then it would take a few seconds. So it took 7 seconds again. And in cast, it still took 3 ms, and the customer ID is 106, which is not correct because we are sending 436. What will you do is that instead of using the request URL, we'll be using the Flask class. All right. So let's send it now. And here I'll have to send the customer ID like this and send it across. Okay. So now I have sent 436 as the customer ID and took 7.13 seconds. Now if I send again, it's 3 milliseconds. What about 106? So it is going and getting it from the database because we have changed the API endpoint, right? So now onwards it will take milliseconds. Let's use one more customer ID, which is 10586. Took 7 seconds, and if I send again, it'll be approximately less than 5 milliseconds. Now what if I use 106 again? It would be in milliseconds because it is already cached. And if you see the response, the waiting is very, very less. It is 1.1 milliseconds only, right? So this is how caching helps, but obviously you have not put timeout. Now what will I do is that let me go ahead and change the customer ID 106 in the database. As of now, we are getting the first name as Fidela, and I'll change the name to something else. So this is the command. I'm updating the first name to 3IAM where customer ID equal to 106. So earlier it was Fidela. It will take some time, and the update took approximately 7.6 seconds. Now let's send the request again. So it is still getting Fidela if you see. Now why that is the case? Because it is cached and there is no timeout. So now what will I do is I'll stop the application and I'll mention a timeout in the caching decorator, which is @cache cast, and here I can mention timeout to be, let's say, 30 seconds. Now let's start it. It is running. Now first time it will go to the database to fetch the information. The first name would be 3IAM. It has changed. Now the caching is for only 30 seconds. So let's wait for 30 seconds and see whether it goes to the database again or not. So after 30 seconds, if I send the request again, it will go to the database. And in the meantime, I'll change the first name from 3IAM to something else as well. I hope 30 seconds are done. And now it is going to the database again. So the execution time would not be in milliseconds, it would be seconds now. So it is 7.66 seconds. So it is working as expected, right? Let's change the name to www.3iam.in. So I'll update it. Currently the name is 3iam and it is going to the database because the timeout is done and it will get the fresh data. The first name would be www.3iam.in, and for the next 30 seconds it will give response within milliseconds, as you can see. So this is how timeout works and this is how caching works. And one very important consideration is that if you are using the request.url variable, you'll have to make sure that you make your own custom key, or else the key would be the URL endpoint. If you do not want that, you can use the Flask type notation, and in this case the key would be this entire API endpoint including the customer ID. And obviously in production most of the times it would be implementing database caching, and you can have application caching also on top of it. A few other things that I wanted to talk about and conclude the topic with is explicit caching and clearing the cache. So I did not talk about it. So let's say what you want to do is that you have a new set of records which are there in your database. You realize that, and you want to clear the cache and read the records from the database and put it in cache back again. If you want to clear the cache, there's a plain and simple method called cache.clear. It can be used to clear the entire cache and you can start it from fresh. There are a few other things like explicit caching, and in this case what am I doing is that let's say there's one or a few records which are read along with all the other records that you're reading from the database. What I mean by that is that this is one record which is called by all the APIs, irrespective of what record or what customer ID you put in the API. In that case, you can actually explicitly cache the record using cache.set method. So in this case, what you do, you read the record from some place and set the cache by providing the key. In this case, the key is admin underscore data and its corresponding value, which is line. Here, what am I doing? Again, I'm reading the line. There's only one record in this finance customer master data. Let me show you that. As you can see, there's only one record. It is an admin record. What am I doing is that I'm reading the line and explicitly putting it in the cache by using cache.set method. The key is admin underscore data and the record is the entire line. And if you have to get the cache data, the explicitly cache data, you can use cache.get method and you'll have to provide the key. And the key is admin underscore data, which I have used earlier. So these are the three methods that I wanted to talk about. And let's see these things in action. The first thing that I want to do is that I want to clear the cache, and once the cache is cleared, I'll read the record again. Okay, and I'll remove the timeout in the code so that records are not removed from the cache. So I have removed the timeout, and now I'll use clear cache to clear the cache and then read the record again and see that the cache was actually been cleared. And after that, I'll read the admin data and cache it explicitly using cache.set. And then I'll read that admin data which was cached in using cache admin API. And I'll use get cached admin URL endpoint to call this API which will read the record from the cache. First, what will I do is that I'll get this customer which is 23006 from database, and it should take around 7 to 8 seconds, as you already know, and I'll cache it. So after the caching is done, I'll clear the cache and try to read the record again. So this is how you'll know that we can clear the cache as per our will also. And again, we are talking about application cache here, not the database cache. This time around, it took around 19 seconds and it has been cached. So the next reads are around 3 to 4 milliseconds. Now, what am I going to do? I'll use the clear cache API to clear the cache. And as you can see, the cache has been cleared. And if I read the record again, it is reading from the database. It would take anywhere from 7 seconds till 20 seconds also. Today it took 20 seconds. So that was the first one. So the next time it took 6.77 seconds, which is 7 seconds. So now again, it would be read from the cache and I can clear the cache all over again. And if I try to read it, it will read from the database. So this is how, using the cache.clear method, you can clear the cache. That is the first thing. So I have read again. So it is taking 7 seconds, 6.73 seconds. Now it has been cached. One more thing, as I told you that the explicit or targeted caching, let's do the targeted caching. And what I want to do is that I want to use that API cache admin to read the record from the file and put it in the cache. So it has read the record from the file and it has put in the cache. Because it has read from the file, you see the execution time is less and the file is in my machine. It is in the same folder as that of the code and there is only one record. That's why the execution time was not that high. If you put it in a database and let's say the database size is pretty big, which is a master data management data store, let's say, and you are retrieving the record from that MDM, typically the MDM sizes are average sized, so it would take certain amount of time. And if you are going to need that data for each and every API, it is always better to cache it. So that's what I have done here. I have cached the admin data, assuming that the admin data is in a large file. Now if I use the get cache admin, it would retrieve from a memory, from cache. As you can see, it is taking only 3 milliseconds, and this is the admin data that I have cached. So that's all about application caching I wanted to show you. And I have to postpone the database caching because what I realized is that if I spawn an AWS Elasticache server, I can only access the Elasticache val key database. Valkey is open source Redis now, similar to open source Redis. We have to use EC2 instance to send the request from. So I do not want to do that right now. I'll show you that in the application deployment or in the project. So that's why I'm postponing this particular exercise, wherein I was about to show you the database caching. Anyway, I'll talk about database caching in one of the projects. Before concluding, I want to talk a little bit about Flask cache configuration. So this is application caching. This is not database caching. These are the different variables that I wanted to call out. The first one is cache type. I had already shown you how do we use cache type. In our case, we had used simple cache, wherein the caching data was in the application server itself, and it used the memory of my machine or the RAM of my machine or my laptop, because I had used simple cache. Then you have file system cache, and what happens in file system cache is that the application server's file system is used to store the caching data. Then you can use Redis cache, Redis cluster cache, and memcached cache. The difference between Redis cache and Redis cluster cache is that for the first one, Redis cache, it's a single engine, meaning that the Redis cache is not partitioned, and Redis cluster cache is where the data is partitioned. Now in this case, a Redis database would be used to cache the application data, and the Redis database can be on the same machine as that of the application server, or on the same server where the application is running, or it can be a remote server also. If you are using Redis or memcached for caching, most likely it would be a remote server, because you do not want to use a caching layer or heavy duty caching layer in your application server. The next configuration that I want to talk about is cache_dir, which is used to mention the directory that would be used for file system caching. And in this directory, the file system or the file would be saved where the data is cached. Cache default timeout, by default, there's a timeout which is for 5 minutes. If you do not use timeout, then 5 minutes of timeout would be used. Then you have cache threshold, and this is an important parameter. So this parameter will tell what should be the maximum number of items that should be stored in the cache. Let's say you mention cache threshold to be 5,000. So only 5,000 items would be stored, 5,000 latest items would be stored. And if you, let's say, send another 100 records, those 100 records would be stored, but the older 100 records would be deleted from the cache. So that's what cache threshold is. And the number would typically depend on the amount of memory that you have on your application server. If your application server has high amount of memory, then the cache threshold number would be high. Otherwise, it would be typically low. Then if you use memcached or Redis for caching, you have to provide the memcached servers, the username and password. Same is the case with Redis. You'll have to mention the Redis host, Redis port, the Redis database. And if you're using Redis cluster, you'll have to mention the Redis cluster parameters. So these are some of the configuration parameters that we have in Flask cache configuration. So that's about application caching. I'm postponing the database caching till the time we do the project.